When we take our first physics class, it's useful to start out by defining what physics is. So we have a nice general definition here, that physics is the study of all natural phenomena with the least emphasis on the sciences dealing with living beings. By all natural phenomena, what we mean is everything we see around us in the physical universe. So, you look up, you'll see the sun, apparently goes around the earth once a day. You want to know why it's bright. Why is it, doing what it's doing? If I throw a baseball or a rock, why does it travel the way that it does? It reaches some maximum height, slowing down, and then it falls to the ground. So looking at the behavior of all these things around me in the physical universe is the realm of physics. We say the least emphasis on the sciences dealing with living beings, just to point out that we're going to be looking at simple things. Throwing a rock, that's pretty simple. It's just one particle traveling on a nice little predictable arc. A living being, a dog, a cat, a human being, taken in total from a physical standpoint, is amazingly complex. So we're just going to leave that for biologists and biochemists and study simple things. In practice, what this means for us is that we're going to be making mathematical models, hopefully simple ones, in order to understand the world. And when we use these models, it's going to help us predict how things are going to behave. If I throw a baseball at a certain elevation above the ground with a certain speed, I want to predict how high it'll go, how far it'll go, how long it'll be in the air. And that's a problem that we'll be looking at during this semester. Now, as we study the universe and we look at objects, we're going to have a standard system of measurement of units. We want to put numbers to things that we see. You can't just put a pure number. You have to talk about reference units, common references for what you're measuring. So for time, we're used to using seconds for measuring durations, and that's going to fit inside our system of units. Incidentally, the system we're going to use mainly is going to be metric units or system international units. When we measure a length in metric units, we're going to talk about meters. A meter is close to a yard. We're not used to using meters in the United States commonly. We're more familiar with feet, with miles, yards, etc. But a meter, just for reference, it's close to a yard. When we talk about mass, the amount of material, the amount of a thing that exists, we're going to use kilograms. We're used to talking about pounds for our weight when we're trying to measure the amount of an object, but a pound is actually not a unit of mass, it's more of a unit of force. So just keep in mind as we look at systems, we're going to be staying in a metric system using seconds, meters, and kilograms. It's worth pointing out that as we go through this semester, these are the only units that we're going to be concerned with, the only units of reference. And there's an amazing number of phenomena that are going to be describable using just these things. If you talk about speed, we're used to talking about miles in an hour. In metric units, we'll talk about meters per second. But remember, when you're talking about speed, you're just using two of these units. Same with acceleration and force, etc. In just slightly more detail, you know what a second is already, but if you had to go for a more accurate definition, or the definition that people started with 400 years ago, 300 years ago, they defined there to be 60 seconds in a minute, and 60 minutes in an hour, and 24 hours in a day, which in the end tells us that a second is defined as being 1/86,400th of a day, and that's a good starting point for our definition of the second. For the meter, the original definition of 1791 was that there were 10 million meters from the North Pole to the equator along the surface of the Earth. So if you walked from the North Pole to the equator and you measured it out, that distance divided it by 10 million, bam, that's your meter. And finally, we had that kilogram unit. The kilogram, there were kilogram reference objects that people used. And this is showing that in France, there is a piece of metal that was used for several hundred years as being the reference unit of mass. In the center of all those glass jars, which were protecting that piece of metal in the center, is a little cylinder made out of, I think it's made out of platinum and silver, electra, a few different metals. But that was defined as being the kilogram. And if somebody wanted to have their own kilogram to use in a scale to measure the masses of other objects, they'd make a copy of this thing, they would take this out, make another copy that would balance out on a scale, and that was the reference unit used for hundreds of years. Now, when we go and use these units, in practical terms, we're going to be talking about things where it's awkward to talk about just meters, for instance. If you have some distance, it's 14.5 kilometers. If you want to express that in meters, you would say, well, it's 14,500 meters. It would be tedious if every time you talked about the distance to Dallas, you said, it's 240,000 meters. You want to say, no, it's 240 kilometers from here to Dallas. So depending on the scale of what you're talking about, you're going to put a prefix onto your units. Like I said, for a meter, it's going to be more common to talk about kilometers when you're talking about journeys between cities and states. If you're talking about something very small, you wouldn't want to say 0.001 meters for a millimeter. It's more convenient to just say 1 millimeter. So all these fundamental units, a second, a meter, a kilogram, and actually in the case of a kilogram, we've already applied the prefix kilo to it, but when we want to talk about mass, we might want to talk about milligrams, centigrams, kilograms, grams. In all these cases, we're going to put these prefixes on and keep in mind what they mean. It's a multiplication by some power of 10. If we look at a table with all the prefixes that we're going to use, we see that we have a pretty broad range. So in the center of this chart, you'll see centi, and that's going to be used for centimeter. That's where you've seen that one applied before. And that's going to be 10 to the minus 2 meters. And when we talk about a kilogram, remember that that's going to be 10 to the 3 grams. And some of these are more useful than others. A microgram, a micrometer is something that we might encounter. But whenever you work a problem and you'll see an expression of a mass, a time, or a distance with one of these prefixes, you'll go to this table or you'll memorize these and you'll see what power of 10 you have to multiply by. And you'll see this worked out in problems. I'll work it out in examples. And after applying it multiple times, you'll have some of these powers of 10, the most commonly used ones, memorized. Finally, this is a process we're going to do quite a bit. As I went through these units, I think that I was implying that we're going to use metric units everywhere, but many times you're going to be told the statement of a problem in terms of miles, in terms of pounds, and we're going to have to do conversions from one thing to another. This just shows a nice simple conversion from 22.5 kilometers into feet. You might be asked, in 22.5 kilometers, how many feet are there? And you'll notice at the bottom of the page in this equation that I took 22.5 kilometers and I multiplied by these terms in parentheses. Now, because there's 1,000 meters in a kilometer, I'd like to say that 1,000 meters divided by 1 kilometer, because those two things are equal, that's just 1. I divided one thing by something equivalent to it. So I can use these conversion factors, these things in parentheses, to eliminate kilometers from the equation, from that quantity. I take 1,000 meters divided by a kilometer. The kilometers are going to cancel out in numerator and denominator, as again I'm going to demonstrate by working multiple problems. At that point, I'm left with a meter. Remember, I'm trying to get to feet, so I multiply by one more conversion factor, which is the number of feet, 3.281, inside of 1 meter. When I do that, I eliminate that meter quantity, and I'm left with nothing but feet, and that's the way I do a conversion. It's worth looking through that conversion worked out here, seeing that you understand it, and you will be doing multiple types of conversions, so you'll get used to this process. In fact, this is one of the most common operations that we're going to do during this semester. It's amazing how many problems will begin with English units in feet, in pounds and miles. But when you work problems out, it's much more convenient, it's much more useful to do things in metric units.